Okay, so this question here, 1.461 grams of sodium carbonate was dissolved in a 250 ml volumetric flask. Calculate the concentration of the solution in molarity, so in moles per litre. Okay, so we have 1.461 grams of sodium carbonate. So to get the moles of that, we need to divide that gram value by the molar mass of sodium carbonate, which is, so just to make it clear, this is the formula that we're using. So the moles is equal to 1.461 divided by the molar mass, which is sodium, so 23 plus 23 plus 12 plus 16 plus 16 plus 16, 106. So 1.461 divided by 106 is 0.01378. And then we have to calculate the concentration. So we've got our mole value and our litre value. So this converted to litres is 0.25 litres, so that's my value there. And so this has to be divided by 0.25, 0.055 molar. There we go, that's the concentration. So what this question is saying is that 20 ml aliquots of this solution were titrated with nitric acid 3 times. The aliquots, just remember, is the liquid in the conical flask, and so it means that it's been titrated with the nitric acid. So the nitric acid is here. We've gotten a titration into my aliquot of my sodium carbonate. And they did a titration 3 times, and the average titer, so the titer is the amount of fluid that comes out of the burette, remember? So the titer was 22.17. So this is the burette, and the liquid in the burette is called the titer. So the average titer was 22.17 mils. Okay, so they did 3 titrations. The average titer was 22.17 mils, and 20 mils of this solution was present here as the aliquot. Okay, so question B is saying write the equation for the reaction here. So that's a good idea to do. So we have sodium carbonate being reacted with the nitric acid to form sodium nitrate, CO2, and water. And we have to balance, so let's pop a 2 there, and let's pop a 2 here, and then let's see if everything, so 2 sodiums, 2 nitrates, 2 nitrates, 1 carbon, 3 oxygens. Okay, we've got 6 oxygens there, so that's a bit, and 2 hydrogens, so that just the oxygens need to be balanced. So we've got the water. So 3 plus 3. Oh no, sorry, that's all right. Yep, we got 3 oxygens and 3 oxygens there and 2 nitrates. So that's all balanced. Okay, perfect. So what we need to do now is think about, find the concentration of the nitric acid. So the question's saying write the equation for the reaction. So because it's saying that, we really should write in the states because the question's asking for a balanced equation. So liquid for the water, gas for the CO2. Find the concentration of the nitric acid. So this concentration here in that average titer. Okay, so we have our standard solution here, which we know the concentration of because we just calculated it. And so we can use that information to help us find the concentration of the nitric acid. So just remember that we stop our titrations when we think the stoichiometric ratios have been met. So when exactly double the amount of nitric acid is present for every 1 molecule of the NO of the sodium carbonate. So when those stoichiometric proportions have been met, we stop the titration because we see a color change, and that point was to be found at a roughly 22.17 mils. Okay, so if we have a concentration here of sodium carbonate of 0.055 molar, okay, that's our concentration, and we really want to know the moles in a 20 mil aliquot, because that's how many the number of particles in that aliquot. So the number of particles in the aliquot, in other words moles, would be the concentration times the volume that I have in liters. So 0.055 times 0.02 moles is equal to 0.0011. And so that's the moles of the sodium carbonate being, well, reacting. So the moles of this nitric acid are going to be the unknown over the known ratio coefficient, okay? So just double. So the moles reacting will be 0.022 of the nitric acid. And so what the question is actually asking, find the concentration of the nitric acid. So the concentration, we've popped in that much volume of it. So concentration is equal to moles divided by the volume. So the concentration is 0.0022 divided by that volume expressed in liters. Okay, so that value divided by 0.02217. So the concentration is 0.099 molar. Okay, so that's that question.